One of the biggest complaints that those who advocate for the inclusion of urban areas in conservation have is that more traditional conservation planning tends to treat cities as homogeneous areas without conservation value. Over the last few videos, we have seen that there are indeed a lot of potential conservation values in urban areas. But cities themselves are also quite heterogeneous. They contain a lot of different types of spaces, from dense buildings to remnant patches of natural habitat, and everything in between. In this video, we will look at the spatial diversity within cities, as well as some of the policies and practices that have led to these patterns and their conservation implications. Although many conservation projects have treated cities as homogeneous spaces, they are in fact quite diverse. For example, this is Halifax. How many different land uses and land covers can you see? How might they vary in terms of how they may support biodiversity in the city? There are heavily built up and industrial areas with few trees and little vegetation overall, like the Burnside Industrial Park. But there are also residential areas with varying amounts of tree cover. There are recreational parks like soccer fields and schoolyards, and parks with more natural ecosystems like Point Pleasant Park and Blue Mountain Birch Cove Lakes Wilderness Area. There are also the more unconventional green spaces, like cemeteries, golf courses, and the public gardens. Think about the spatial arrangement of these different types of urban landscapes. How might some of these green spaces work together to support biodiversity in Halifax? Are there any areas that might be potential ecological traps? What barriers to wildlife movement do you see on the landscape? While many patterns of landscape heterogeneity occur naturally, the spatial patterns of different landscapes in cities don't emerge out of thin air. They are the products of decades or even centuries of social choices and policies. These policies were often shaped by and designed to uphold systemic racist and classist biases. And even though some of them have not been official policy for decades, we can still see their legacy in the spatial patterns of cities today. The distribution of impervious surfaces, urban heat islands, green spaces and tree cover, pollutants, resource distribution, and disease dynamics are all the result of these policies and social processes, and we'll get into some more specific examples later in this video. In addition to the undeniable, lasting, and continuing legacy that these choices have had on people, they have also influenced ecological and evolutionary processes. In order to affect the long-term success of urban conservation and sustainability, these issues of environmental justice and civil rights need to be addressed. This figure from a reading led by Chris Schell from the University of California at Berkeley shows the influence of these social and ecological processes in urban areas, and also defines a few key terms like inequity and intersectionality, which are essential for understanding the construction, influence, and dismantling of these policies and their effects. One of the most robust and well-studied links between socioeconomics and urban ecology is what is known as the luxury effect, which suggests that biodiversity and ecological health in general is positively correlated with neighborhood wealth. Our reading led by Chris Schell outlined the luxury effect's influence on a few different ecological patterns and processes. First, affluent urban residential neighborhoods generally have a greater vegetation cover, especially tree canopy cover, and a higher diversity of plants in general compared to their less wealthy counterparts. Further exacerbating the issue and highlighting just how long the impacts that social policies can have on biodiversity is that green spaces in wealthier neighborhoods tend to be larger and older, meaning that they typically have older and more established trees and other vegetation communities, which provides greater support to other levels of biodiversity. In particular, bird species richness and abundance has been shown to be highest in wealthy neighborhoods with a high tree canopy cover. For example, take a look at these maps of Toronto on the left-hand side of the screen, which show the patterns of median income and tree canopy cover by census tracts. While not a perfect relationship, there are remarkable similarities between the two maps, and there does appear to be a pretty clear correlation between income and tree canopy cover. The uneven distribution of vegetation, especially trees in a city, means that heat is also unevenly distributed, because trees help to reduce the urban heat island effect by providing shade, deflecting radiation, and by releasing moisture into the atmosphere. Because lower income neighborhoods tend to have reduced tree and vegetation cover and increased impervious surface cover, they tend to have higher surface temperatures. A 2019 investigation by NPR into the urban heat island effects of 100 American cities found that poorer neighborhoods can be as much as 10 degrees warmer on summer days than their wealthier counterparts. For example, look at the map shown here comparing heat and income in Los Angeles. Like the income and tree canopy maps of Toronto, we can see that there is a clear pattern of lower income neighborhoods being hotter than wealthier ones. It's a similar situation with air pollution, as pollution sources tend to be located near low-income neighborhoods, meaning that low-income folks are the ones who bear the brunt of the health impacts associated with air pollution. But it also means that these areas tend to have lower biodiversity, as both plants and animals may also be affected by pollution and subsequently pushed out of these neighborhoods. Of course, the luxury effect is not universal, as the history of urban development, individual choices, and societal norms all influence the relationship between wealth and biodiversity. One example that is given in our reading is lawns, and yard plant diversity in general. Wealthier folks tend to intensively manage their lawns so that they have few, if any, species other than turf grass, which does not support a lot of other biodiversity. A big part of urban biodiversity conservation is working to eliminate the uneven distributions of vegetation and other biodiversity resources throughout a city. But to do this effectively, you have to understand how these patterns emerged in the first place. We just saw that wealth at the neighborhood scale is a pretty good predictor of urban biodiversity patterns, but as Dr. Schell and his colleagues pointed out in our reading, in many cases, the racial composition of a neighborhood can be an even stronger predictor. Multiple studies have demonstrated that air pollution exposure and urban heat island effects are magnified in majority-minority neighborhoods in American and Canadian cities. But we have to think about how these segregated neighborhoods came to be in the first place, and the policies and social structures that have them in place and have allowed for environmental injustices to occur. One particularly notorious example of how structural racism has impacted the spatial dynamics of cities in the US is redlining. Redlining was a practice that started in the 1930s and was a policy that graded neighborhoods based on their perceived amenities and burdens, including environmental quality, proximity to industrial facilities, and racial composition. Neighborhoods were classified on a scale from best to hazardous, and those in the lowest, least desirable category were outlined in red on maps. The redline neighborhoods were assigned to banks and other mortgage lenders to steer clear. The result was that Black Americans were routinely denied mortgages and the ability to move into the more desirable neighborhoods, creating the segregated neighborhoods that, in many cases, still persist to this day. And many neighborhoods that were redlined nearly a century ago remain poor and underserved. Redlining had huge effects on the mainly Black and other racialized people that it discriminated against. It prevented their upward mobility and accumulation of wealth and kept them in underserved neighborhoods. But it also had environmental consequences which further marginalized the people who lived in and continue to live in redlined neighborhoods. In many cities, it's easy to spot which neighborhoods were redlined just by looking at satellite imagery. Redline neighborhoods have on average 21% less tree canopy cover than the neighborhoods that were designated as the top quality. And the trees that they do have tend to be younger and smaller, meaning that they don't have as many social and ecological benefits. They also tend to be much closer to sources of current or legacy pollutants. For example, take a look at the maps here that show the patterns of how neighborhoods were classified in Baltimore during the redlining era and the tree canopy covers today. It's also important to point out that while redlining in the United States gets a lot of attention and its effects have been well studied, redlining was also an issue in Canada, including right here in Halifax with the community of Africville. Africville was a small but thriving Black community in Halifax that was started by Black loyalists who came to Nova Scotia under the promise of land and freedom. But the land they were given was the small pockets of infertile land at the top of the Halifax Peninsula. Residents there had to fight for the same basic necessities that were provided to other white Haligonians, and many residents never got running water or the sewage system. The community also received none of the millions of dollars that went into rebuilding the rest of the city following the Halifax explosion, which badly damaged many homes and other structures in Africville. Instead, the city gave Africville a prison, a dump, and an infectious disease hospital, which brought about health hazards and further devalued the houses in the neighborhood. In 1964, the city forcefully displaced the residents of Africville without consultation and razed the community to the ground for a highway that was never built. Today, the site on which the community of Africville once stood is a park with a small museum dedicated to telling the story of the community. In addition to the effects on human health and well-being, redlining and other policies that upheld and enforced systemic racism have influenced ecological and evolutionary processes in cities. New research has also shown that the spatial arrangement of vegetation cover is linked to evolutionary change, which means that segregation-driven patterns of vegetation cover are fundamentally linked to the evolutionary trajectories of urban biodiversity. In racialized neighborhoods, the green spaces tend to be smaller and more isolated from one another. Think back to our discussions in this class on island biogeography. This means that these neighborhoods are likely less biodiverse than wealthier ones with more and larger green spaces. This is further compounded by the amount of highways and impervious surfaces that tend to be found in racialized neighborhoods. Impervious surfaces are generally associated with the reduced movement of wildlife across landscapes, which we know results in more isolated populations, reduced gene flow, and lower adaptive capacity of species. In urban areas, tree cover can work to overcome these effects, but because tree cover is lower in redlined neighborhoods, these areas have reduced connectivity and are more likely to be ecological sinks or ecological traps that are unlikely to be able to support populations over the long term, leading to local extinctions. This figure is from our reading led by Dr. Schall, and it shows two hypothetical cities. In City 1 on the left, the green spaces are evenly distributed throughout and continuous from green to redline districts, compared to City 2 on the right, where green spaces are heavily skewed toward wealthier neighborhoods, as is the reality in many cities today. Because of these different spatial patterns, connectivity varies dramatically between the two cities, leading to a selective gradient that may result in different distributions of trait values of species found in the different neighborhoods. It is assumed that both cities have the same species assemblages in the A or green line districts, but that in City 2, both species richness and diversity decline as you move from the green to red line neighborhoods, which affects the food webs in each of these cities. In City 1, the system is likely to be more diverse and interconnected across districts compared to City 2, which is much more vulnerable to disturbances and extinctions. So how do we put all of this into practice in urban biodiversity conservation? The key is to look at urban spaces through an intersectional lens and to take a more holistic approach to understanding the patterns and processes that shape urban ecosystems. Because systemic racism built many of the patterns of ecological degradation and biodiversity loss in cities, it needs to be addressed and dismantled to solve these problems. In all conservation efforts, it is important to listen to and address the concerns of the people who live nearby and who will be the most affected. But this is especially true in urban areas, where research has shown that without local community support and buy-in, projects are doomed to fail. White-led environmental and conservation movements have a long history of marginalizing racialized folks and have often worked to reinforce state-sanctioned patterns of racial segregation and the criminalization of racialized people in public spaces. There is a need for conservation approaches in cities to be rethought and rooted in justice, equity, and inclusion. One key way to go about making this shift is to not only include but center the communities who are most affected by these decisions. An example of a project that is working within this approach is the Vacant to Vibrant project, which we heard about in the last video.